Chapter 10 Gases. Exercise 10.41 Part A. What volume does 0.111 mole of helium gas at a pressure of 0.98 atm and a temperature of 315 Kelvin occupy? Two stick figures. We'll use this equation. PV equals nRT. This is the gas law. We'll just need to plug in the numbers. The pressure is 0.98. The volume is unknown. We have 0.111 mole. And then let's enter the value of temperature first. 315. The unit of R should be atm times liter, because over here we have liter here. Atm times liter divided by moles divided by Kelvin. And when that's the case, the value of R is 0.08206. Alright, so this is the equation we need to solve. Both sides divided by 0.98. We'll get the answer 2.9 liters. Alright, I just want to talk about this R. R is 0.08206 only if the unit is atm times liter divided by mole and Kelvin. And because 1 atm times 1 liter is 101.3 joules, so if you want to use a different unit, joule over mole K, this value should be 8.31446, which is this number times 101.3. Let me show you the value of R here. So this is the value of R. Alright, 0.08206 liter atm over Kelvin and mole over there. Okay, part B. Would the volume be different if the gas was argon? Well, we use the same gas law for all ideal gases. Argon and helium, they are real gases, but they are close to ideal gases. So since we're using the same equation and the same values for pressure, R, number of moles, and temperature, the volume would be the same. If the gas was argon, because the ideal gas law is dependent on the number of moles of the gas, we do look at the number of moles of the gas and not the mass. We don't have to worry about the mass. Well, of course, 1 mole argon weighs more than 1 mole helium, but we don't worry about the moles. If you look at the equation, it's PV equals nRT. Nowhere we see mass. Over here, this is the number of moles, not mass. So as long as they have the same number of moles, well, we get, and of course, same pressure, same temperature, we'll get the same volume. So roughly, if you have 1 atm pressure, roughly 1, and temperature roughly 25 degrees Celsius, the room temperature, the volume is always roughly 25 liters. Alright, roughly. It does not matter what gas you have, it's roughly 25 liters, or it's close to 24.5 liters, but anyways, close to 25 liters if you are interested in this fact. Now, what if the mass of the gas is given? You need to find the molar mass of the gas and then calculate the number of moles in here and then plug in temperature and pressure. Now what if you have a mixture of gases like air? Well, in that case, you need to get the number of moles of nitrogen, the number of moles of oxygen, and you have to sum it up. And then you get this in.